Unmute. All right. So today, what I will do is start with screen sharing on the Zoom meeting. And I want screen 2. Share. So there we go. All right. So we are troubleshooting, and I had you before class skim this article. I will post it so you can actually get to it. But the Tomcat was an F-14, and this is the story of how this guy designed it. And the story about this particular person is not his story per se. It's a friend of the family's that wrote this story about him. So if you're looking for uber geekiness, this doesn't have it, but it gives you a glimmer of what it was like before they had 8 billion transistors in an IC. And what I'm going to do is pass this around. This is fiber cable, and it has the cladding and the insulation around it. The cladding is the plastic stuff that goes around it. Feels like rubber. The little skinny orange one, that's the actual cable, sort of. There's cladding around that one. And if you look down inside of it, you can actually see the glass fiber. I used to have a little piece sticking out, but somebody stuck their finger on it and got a piece of glass stuck in their finger, and you can't see it now. And then the other thing that's hanging on by a piece of tape, that is a single solitary transistor. Okay, that's how big they are when you use them in hobby type stuff. So when we're saying 8 billion transistors, that's a lot of transistors. Okay, so you just pass that around, take a look at it, get an idea for some of this stuff. But troubleshooting today, we'll start with some stories. Canvas didn't work. You couldn't see the assignments. I didn't know you couldn't see them until somebody tells me. Oh, okay. Then I ask one person, and then I decide, okay, is it one person's problem or everybody's problem? That's why I asked. So it was an everybody problem. So that kind of points to it was something I did wrong, because I'm the one that does it, quote, everything on the shelf. All right. So we got that figured out. Earlier this morning, we were having wonderful time on his little PC here, getting Linux Mint installed and getting the device drivers to work with the wireless. The switched wireless we have on campus is unique, and it has a tremendous amount of security tied into it. So once you get your wireless working here, now most of you use your phones and go click, 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 and it just worked. Or if you use Windows, you went click, 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 it just worked. But if you're using Linux, it didn't just work. You have to go in and tweak things. And what we ended up having to do on his PC is actually download a driver set that is encumbered and licensed to enable his wireless card to talk to this access point, which is written, this is created by Cisco, and they have a specialized driver set on their cards or their wireless chips. They kind of work with other manufacturers that you have to have a specific license. Microsoft already pays for this. Apple already pays for this. Your phone manufacturer already paid for this. But the Linux box is open source, doesn't come with it. Encumbered, okay? So troubleshooting is a big thing. And today we're gonna have some fun. I had Gabriel sent at this machine that's got little lines going over it, as you mentioned, yeah, on Monday. It's kind of irritating, yeah. And what we're going to do is we're going to walk through kind of a troubleshooting process of how to fix it. Now, I don't know if you can all see his screen, but if you kind of turn around and take a look at it, it has these little tiny lines dashing all through it, and it's quite irritating, and it comes and it goes. And we're trying to figure out what's wrong? Oh, it's the monitor. So what do? Just change the monitor? We could. Yep. There's a mini display port adapter, and it supports 4 display ports. And what we could do is turn the machine off, move it to another connector. So let's talk a little bit about how the machine looks, so you know what we're troubleshooting, since you can't really see everything I'm doing or we're talking about. I brought in another piece of hardware. It's this monster here. And this one has a slightly older card in it. Okay, you see that this is the video card. The ones underneath your desk have a place for 4 individual monitors. Okay, so you can have 4 monitors on one PC, which is really cool. So we're trying to figure out why this thing goes like this. So first of all, we need to understand the edges of the problem. That's always step 1. What problem are we trying to solve? What does done look like? You keep those 2 things in mind, it will help you even in personal relationships. Okay, to some extent, not everything. Okay, so the edges of our problem, it's related to a single PC in a room of 30. Okay, and we know it's on that PC, and it's related to video. So the machine boots, the machine runs, so we can pretty much say to ourselves, do we need to worry about networking? Probably not. What about having enough RAM? Probably not. You getting the idea here? We get this big problem, and we're trying to break it down into smaller pieces by eliminating what we know works. Okay, and then you can say, okay, the problem is related to the video subsystem. What makes up a video subsystem? So our edges are the video. Okay, so what's in a video subsystem? Exactly. On these particular machines, we have relatively high-end hardware. On your machine, could you, that PC in front of you, lift it up so everybody can see it. Do you think he can take out the video card and replace it? No, because it's actually soldered in to the board. So if we have a video problem on a notebook, the edges of our problem domain change. Does that make sense? Okay. Now we're just walking through this in a reasonable idea of where troubleshooting comes from. And today is some storytelling about troubleshooting to kind of open up your brain, because you have a remote that works maybe on your TV or stereo or whatever, correct? Does anybody know how those things work? There's a few of you that have taken the time to figure it out. Yeah, it uses, go ahead. Oh, yeah, infrared. Infrared. Yeah, go ahead and, if I don't hear, feel free to really yell, because, it's, yeah, I have to turn my hearing aids down so I don't sound like I'm screaming, and so you can hear, keep your hearing, But anyway, a problem domain. On these machines, we actually have a CPU, an extra card, and some cabling, and the monitor, okay? One thing you learn the hard way is always check the cabling. Now, let me tell you some stories. This one goes to the days of phones connected to the internet. Okay. This was way before the internet, and phones were actually connected over a serial port. And this particular piece of equipment was called BTOS and CTOS was the operating system. And they had stuff that was light years ahead of Windows. And it never took off because it was vendor lock-in, did not play well with others. Okay. So that company's gone. That operating system is gone. Everything that they use to support that operating system is gone. So you can read about it in the history journals of all these things that talk about vendor lock-in and how they went out of business. Why do you think Microsoft is beginning to embrace open source? They have to. They need to stay alive. Open source is taking over the world, okay? So with our video system and that particular machine, it actually used a headset with a serial cable, and you could actually take phone calls on a tower type machine on your desk. And it was up in Lodi at a bank. And we could not, for the life of us, figure out what was going wrong. The problem was intermittent. There was about 20 phones, and the phones would sometimes work, sometimes not. I think I took 4 or 5 trips to Lodi and troubleshot it. In those days, we used logic probes and digital voltmeters to solve the problem. And when the problem went bad with an intermittent problem, it's really hard to find root cause because you can't duplicate it. If you can duplicate the problem, you can fix it. Put that in air quotes, put it in your brain, because if you can't duplicate a problem, it's very, very difficult to fix it. Okay. This one's easy. It's happening all the time. Okay. So with this problem we had on the thing, I found it down to the connector. Mr. Bossman wanted to save money on the installation and bought inexpensive cable and inexpensive phone cords, you know, RJ11 type things. Well, the RJ11 jack looks something like this. And inside of it, if you've built cables and networking, this is what it does. And it's got these little pieces of metal, and you put the cable in and you crimp it, and the cable gets pushed into the metal, and then you have your connectors. If you've looked at an Ethernet cable, that's what it is. That's what this is. At the end of this thing, there is a crimp. There's metal. And the problem was the plastic wasn't within spec. So I had to trim the edges off each connector in their building to get that phone system to work. It was a physical problem with the cable that wasn't making an actual connection. And the troubleshooting process was all over the map, okay? Because it was intermittent, okay? And I've got a gazillion stories like that about how the little things bite you the hardest, okay? All right. This room, each one of these machines have a terabyte SSD. They came with heat sinks. The heat sinks fit. Almost. When you put the heat sink on the 1 terabyte SSD drive and you mount it in the motherboard, it pulls the SSD card just ever so slightly out of the socket. So it won't boot. You take the heatsink off, which it really didn't need anyway. It now fits and it works. Those are the type of things that give you the ability to ask for a raise. Because this is the kind of thing that most people can't solve. What happens when your PC doesn't work? Did you reboot it? Did you refresh your cookies? Refresh your browser, try a different browser. And that's usually all the further it gets, right? But what happens if it's a little deeper problem and there really is something wrong? How do you find it? Problem domain. What problem are you trying to solve? What does done look like? And then now we have this idea, okay, here's our problem. This is what done looks like. So let's kind of work our way that way. Now, what are some of the things we need to consider as we're working towards completion of done? Do we have the ability to find out if we're halfway fixed or not? Sometimes you can, sometimes you can't. In project management, you cannot have a woman have a baby in a month by getting 8 other women. Okay, it doesn't work that way. You can't, project management does not work usually by adding more people to it. Usually you have to streamline what the work is getting done. Okay, so we have to look at do we even have the ability to find out if we're halfway fixed or not? Now, in our situation here, we kind of have we could do a quick slap and find out if the problem went away or not. Okay, that would be replacing the monitor. That's a quick way to see. Bingo. But what if you want to solve the problem at a deeper level before you even get to that? What if it's in Hawaii and you can't really change the monitor? Okay, we need somebody with arms and legs to go change the monitor. So they drive 2.5 hours in a big circle on Hawaii to get to the location, and they change the monitor. They charge the company $900, and then they go home, and the problem's still there. Now what do you do? Well, that's a legitimate, that really is a legitimate way to solve the problem. Okay, let's put that one on hold. Okay, so we're talking about the video here. Okay, and I talked about the Vox system I worked on, and now I'm going to talk about this wonderful problem that we had at Foster Farms. This was a true story. The Foster Farms was, when I was there from 97 to 2005, had this philosophy: buy the best of breed. In other words, you find the best inventory warehouse management system, you buy the best financial system, you buy the best maintenance solution, and you have all these best solutions, and they don't talk very well to each other. So what do you end up with? One giant mutt. Okay, one big mutt. Okay, best of breed doesn't always work because I can't remember the cost, $10 million Red Prairie inventory system did not talk very well to SAP Enterprise Warehouse. In fact, there was no RFCs, there were no APIs, there were no way to connect the two systems. So what did we end up doing? Let me show you what we did. All right. This is so true of so many things. What is a text document? a document full of text that there's nothing in it, right? No formatting, no brains, nothing there. Okay. So I'm going to say hello. Okay. And I'm going to give it a name called hi.txt. I'm doing this on Windows, so I'm going to stumble a minute. And it's in the desktop. Okay. Hi.txt. All right, we'll close this. Go down to here. Change directory desktop. This is how I know. This is how I get around Windows. There's my hi.text. Is XXD here? Nope. Okay. Let's do it. Now that I have this installed, I'll use this Moab tool, because then it'll give me, because what I want to do is show you some interesting things here. And it was on the desktop. XXD hi.text. That's all that's in it. This is what you're going to learn in this class. What are you looking at? Ones and zeros, folks. This is not a translation of binary to decimal. This is a representation of binary to decimal. This is why what I'm talking about applies to you. This binary low-level stuff is how you solve expensive problems. And I'm leading up to this, okay? So hi.text doesn't have much in it, does it? So let's do something else with that same file, or a file similar to it. Let's go to open a new one. Let's say new document. Okay, let's use Word. Okay, I'm going to double click on it. Wait 2.5 hours for it to load because it's so fat. And I'm going to type in hi. That's it. I'm going to say file save as, put it into the same directory, desktop. Whoops. I need to rename it now. So let's rename it. Hi.docs. Oh, big point of reference. Case. Linux and assembler are case sensitive. C++, Python, case sensitive. Windows as an operating system is not. So on Linux, uppercase hi.txt is a separate and distinct file than lowercase hi.txt. Does that make sense? That's foundational. You got to know that. Okay. All right. So I now have this new file, hi.text. There it is, or docs. Now let's see what's in that one. Wow. Look at all that fun garbage. For the same exact file. Now, this is, I'd solved a lot of printer problems by doing this type of thing, capturing the print stream, going and figure out what we need to do for a filter, and then change the filter so we can actually get it to print right. Those types of things you don't need to do anymore. But the thing is, you still need to know what's going on to solve those types of problems, okay? You can print to PDF. Anybody looked at a PDF file? They're a mess. There's all kind of garbage. You can actually write code that makes a PDF file do stuff, like calculate. You can actually take, it's it's a programming language, stack-based programming language based on the idea of fourth. You can actually write code in PostScript, which is the precursor to PDF, that actually calculates numbers and prints them on the page with no calculation going on in the computer, just on the piece on the printer. It's called the formatter board. Pretty cool. Crazy stuff you don't care about these days, okay? But those are the things that help you troubleshoot the problem that we're getting to. That's right. PostScript is actually a really handy thing to learn because it's kind of foundational to all PDFs. And the conversions from PostScript to PDF are fairly straightforward, but conversions from PDF to PostScript are encumbered. They need licensing. So, but what's PDF? It's the universal document that people use all the time. They use it for ebooks. They use it for legal verification on signatures because you can lock a PDF unlike a docx file. Like I can go into this docx file and edit the hex and actually change whatever it is I want to change in it and send it down the road and nobody's going to know any different, i.e. bad guys do that, okay? But back to this problem here, at Foster Farms, they had the Red Prairie system and SAP. Everything worked fine in Foster Farms and Livingston campus. Well, we put remote connections up in Kelso, Washington, where we were using fractional T1 lines. That was all you could get, no such thing as fat pipe. And it was literally taking them 20 minutes to get logged into Red Prairie. 20 minutes. So what does SAP and Red Prairie tell us? These high-paid consultants that borrow your watch to tell you what time it is, they're telling us you just need a fat pipe. What's the cost differential between a fractional T1 and something like a full-on OC1, which is they were recommending? Millions of dollars a year. So the lead network guy and I said, no way. What'd we do? We used Wireshark and we captured the traffic of when people were trying to log in and from the time they actually got a working screen. There was an image file that was being sent over this narrow pipe that was 8 gigabytes. 8 gigabytes for a single splash screen. So we bring the big honchos of those two companies in saying, found the problem. It's not our pipe, it's this. And then they said, oh, we can turn that off. Had we not done that, millions of dollars would have been just thrown out the door. It's okay to ask why. And it is a true problem-solving project management tool, and it sits in the category of 5 whys. I find this extremely effective, but you have to level it with somebody. You have to say, today we're going to try to solve the problem, but we are going to use 5 whys. Because it can be very irritating to work with somebody who keeps asking you why. You want to punch them in the nose by the time you get to number 4, okay? But it's very effective to solve the problem. And I have found the best way to solve it is to let the other person know we're going to walk through this process and we're going to ask why 5 different times for 5 different use cases. Like, for example, root cause analysis. This gets into more of the troubleshooting. Do you need root cause analysis? Of course you do. Do you? Let's take a for instance. What was it? Hula had the big outage lately. Amazon Azure, they lost all their Ubuntu instances when they updated from 22 to 22 point something. All of them disappeared. What's the root cause? Well, you find the root cause this, root cause that, root cause this, and you find out that the operator was sleep deprived because he had to take his cat to the vet. Does that root cause help you solve the problem? So in your problem domain, the question, what does done look like, answers that question. We really don't care if the person was sleep deprived and their cat was sick and they were worried about their cat. We want to know what the process was that was broken that allowed that mistake to happen. Okay. Can you kind of see where this troubleshooting world goes? It's kind of a big thing. And it's really hard to kind of teach you how to do that. Okay. I'm doing my best. But here's the pieces that I've learned through observation of what makes things work to be a hotshot troubleshooter. One, you know what you're talking about. Knowledge acquisition, glossary acquisition. If you're troubleshooting a networking problem, you better know how and why. Hey, I can't get on the internet. Why? Well, is it DNS? Is it IP? Is it DHCP? Do you know even what I'm talking about? Those things, the theory of how something works, will help you troubleshoot. Okay. So these bigger pictures on troubleshooting is when this came up in this class, I said, you know, this is going to be a lot of fun. My success rate in teaching troubleshooting is pretty low. People who have a natural knack get it. And I have not figured out what that natural knack is, other than the closest thing I put my finger on is they can work with their hands. In other words, they know how to twist a winch. They can build a birdhouse. They know if I do this, that happens. That's the only thing that's kind of is a common denominator. Good gamers may or may not be good troubleshooters. Okay, it's because troubleshooting in the game arena is not the same as a technology arena like troubleshooting this image. Okay. I don't really know what the specifics are. I'm just going to tell you is the more you know, the better you get at it, especially when you break a lot of stuff. I have learned and forgotten so much stuff. And we were talking today is that he got his PC working using Linux Mint for the wireless. And I'm going to recommend this to all of you because it was actually one of our former students, Salazar. He is now a high-paid $500,000 a year security consultant all over the country. He's done talks over at DEF CON, Black Hat. He showed an exploit of how to use Samsung Pay and actually snarf the payment credential so you could actually use it for somebody else. He did all that original work. So but I asked him, knowing what you know now, what would you do sooner in your career? Start a blog and explain what I'm learning and how I'm learning it. And that's the advice I just gave you. Build a portfolio. How are you going to know what you know unless you document what you know? Because English is another programming language where it takes your brain ideas and puts it into another brain. So knowing how to write a complete sentence with punctuation and capitalization is important. My students that are making those monstrous salaries know how to communicate in written word, because if you're going to work remote, you have to be able to get your ideas on paper. Okay. And Salazar he's fluent in Spanish and has trouble with English. So he's found his niche doing security consulting in South America. He's just, you might have seen him at DEF CON and Black Hat. I don't know if he had anything going, any talks going or not. Yeah, that was his work. He did that a couple years back, and he started here. But he didn't come here to learn security. He spent hours and hours and hours of it on his own. He spent time in the woodshed. There's no shortcut to being good. It's like being a musician. You want to play guitar really well? Takes practice. You want to be a good programmer? Takes practice. Okay. There's no secret. You don't have to be a genius. Now, some of you are far more adept at this than others. I'm going to tell you, do not compel yourself to anybody else but yourself. It's time in the woodshed. They've just spent more time practicing than you have. You all catch up if you practice. That's it. It's not magic. It's hard work. Okay. Computer science is not an easy major. It's not for example, we were talking about calculus. I never used it in industry, but I do use a ton of stats. I mean, stats everywhere. Stats were important. Knowing how to communicate other disciplines is important. Okay. All right. So I have other troubleshootings to go, but let's go back to this guy here. So I'm going to do a remote session into that machine, and that's 14, right? So SSH. Did it stop it by wiggling the connector? So what's that say about our troubleshooting big picture problem? Check the cables first. Is the power on? And I happen to know that that is an issue with these machines, because what have they been doing for the past 2.5 years? Sitting here spinning, doing nothing. Nobody's typed the keyboard. Nobody's looked at the monitors. I jack in and update them, reboot them, but that's about it. I don't even know if they display or not. So it was kind of fun to watch. Oh, they're mostly all working. Well, that's cool. Even after I upgraded them all to SSD drives. So the connector on the back. So what does the connector on the back look like? On these machines, it's a display port. And these types of connections really do go bad. For example, if your PC is in a garage and your garage is really, really dusty, your PC is going to get dust. And then when it rains, the humidity goes up, the dust gets moisture, causing partial shorts. So your machine all of a sudden goes quirky when it rains. What's the fix? Knock out the dust. Okay. So the troubleshooting is a fun topic, and I can spend a lot of time telling stories on it's a lot easier to explain successes and failures from a standpoint of what did and didn't work. But when you have to troubleshoot a problem on your machine, that's when you realize this is hard. So I recommend all of you break something just so you can fix it. Get an old PC, put on Linux and make it work, or not. Get an old phone, root it, brick it. Oh, well, I mean, old phone, not fancy. You don't want to burn up anything fancy, okay? But learning this stuff is there's really no shortcuts. You just kind of get to learn it. But I will say that I happen to be lucky. Well, let me explain some of my failures. My very first programming class was an abysmal failure. It was terrible. I was a music major, played trumpet. I sucked at trumpet, but that's beside the point. But I met my wife at Stan State. And we took this winter term programming class in BASIC at Stan State. So that's 4 weeks to learn programming. And it was taught by a fellow from MJC. I didn't know that till many years later, but I didn't get it. Neither did my wife. She'd get mad enough to on the keyboard. And they were terminals in those days. They weren't monitors. They weren't keyboards and mice. There were no mice in those days. It was an abysmal failure. I did not understand programming at all. Then I come back to JC, and my first programming language that I took officially at MJC was assembler. And then all of a sudden, all the lights went on. I get this. Well, why? What's my background? Digital electronics, logic probe, ones and zeros, gates. It made sense. Now, do I recommend other people do that? No way. Unless you happen to have a strong electronics background and you can read schematics. I do not recommend assembler as your first programming language. Python is my favorite tool to teach beginners because in one semester, I can get you this far. Using C++, I can get you this far. So if you take my classes, I make you write a lot of code because when one of the DPIs of tech at Twitter tell me that he didn't write too much code here at JC and he had to learn it all later, I said, well, I can change that. So there's a lot more coding in my classes. If you search online, you can find people that said, I wish I knew this before I graduated in computer science. And they all say the same thing. Learn how to solve practical problems. Learning the theory is great. Yes, you can write a binary sort algorithm. That's great. But learn how to solve real problems with real data. How do you do that? Find problems to fix. Volunteer. Go learn something. It's the pragmatic side that they all say they wish they knew more of. Practice. Practice. That's it. Practice. Okay. All right. So wiggling our connector fixed our problem. Okay. Now, part of what we get into in this class is hardware in general. And I passed around a single piece of hardware. Okay. Now let's have some honest discussion here. How many people know how to get to this on their PC of choice? Come on, be honest, raise your hand. And if you don't know, raise your hand anyway. It doesn't matter. This is called the command line. Every operating system I've ever touched in my 30 plus years has one. This is the way computing used to be done. Only the command line. This is where all the great jobs are. How many have added extra users to their Windows machine? So your sister or brother can use it. Okay, that couple of you have done that, not too many. Okay, all right. Let's take it for example. You get hired as a Windows admin for a small IT firm. And this small IT firm just hired 10 people. How do you create their users? Click, 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 click. User 1. Click, 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 click. User 2. You can do that, but you can also write a script. And the script runs at the command line. That's why cloud DevOps. Do you know how to do Linux? Do you know how to write Bash and Python? Well, that's how you make this stuff work. PowerShell, Bash, Python. Those are the big ones. And now you can run PowerShell on Linux and you can run Bash on Windows. You can get an awful lot done and not even have to move from your desk. Like when I update all these machines, I don't touch each one unless it's hardware. Then I don't have a choice. Okay. When I update the PCs, I can just run a script and take care of it. Okay. Where's it going? Oh, hardware. Now this guy's still on, right? Okay. Let me turn him off. All right. How many have done this to their PC? All right, most of you at least gutted it to see what's in there, and you go, "Oh wow, look at this stuff." Ugh, yuck! I'll leave it alone. I don't want to touch it. Okay, that's legit. If it's your primary machine, I do not recommend you poke on it because you might break it. But now you're really motivated to figure out how to make it work because you have a homework assignment due at midnight. Okay. Static is a thing. So be careful with static. Make sure you're grounded. And an easy way to get grounded is find something that's already grounded, touch it, then you get grounded, and then you can work on your PC. Because everybody's seen static electricity. You know, you walk across the carpet and you touch something, you get a spark and go that far. Well, that does havoc on electronics. It will fry all kinds of things. Okay. So make sure you're grounded before you do anything on a PC. But this has a fan on. This thing down here is the video card is toward the bottom. That big fan in the middle, that's the fan that goes on top of the CPU. And those vertical things, that's memory. Okay. All this stuff is related to the low-level hardware. And I have a lecture, and I haven't figured out if I'm going to bring in this stuff or actually just give you the recorded lecture of, I have this survey of old hardware of what computing used to be like. Trust me, folks, the good old days weren't so good. It was very painful to do a lot of things. It just took to get anything done. Okay, just because you didn't have any options. Okay, now this I'm going to pass around is, let's see if I can point to, there we go. It's really hard to see, but I'm holding it upright, and where my finger is, I'll pass this around. This is the 2-transistor computer. This is a copy of what's on your assembler language. Okay, I'm going to pass this around so you can look at it, so you can kind of see what all those symbols are. Because by the end of the semester, you're going to know what those symbols mean. So right now, it's like, what are we getting into? Yes, it's an unknown world, and it can go very, very, very deep. Basically, we're going to be on a kayak on the top, skimming across this ocean of assembler stuff. Okay, so we're not going to have much chance to really get deep into the bowels of how this stuff truly works. We're giving you an idea of saying, oh, that's assembler. I can tell by looking at it. What's it do? I have no idea. That's kind of about where you'll be at the end of this class. Okay, so hopefully it reduces the fear of what assembler can do or not do, and so on. If you have an electronics background and you're familiar with schematics, this is not one. This is sort of like a digital electronics schematic. This is more of a logic diagram. Okay, so in our big picture of what we'll be looking at is, let me bring up my canvas shell here, and I will show you how this all kind of fits together. All right, I'm going to bring up mine here. All right, so next week we'll be talking about information and bits. What is information? And there is an entire discipline called information theory that talks about how to encapsulate human knowledge into a representative form for computers. Now, how do you capture knowledge for AI? That's a lot of knowledge. This is why they say training data. How many heard this topic in this category here? Convolutional. Yeah. CAN in conjunction with AI. Sometimes I've seen it as GCAN. One person. That's what I would expect. It's very, most people don't know any of this stuff because you don't learn it here, and you might learn it at a four-year school if you actually take an AI class. But what this is a generalized convolutional network. What it does is that you have an AI box over here. This is your target, and you have an AI bad guy here. And it sits there and tries to confuse the AI. So you have AI training AI. Convolution. The guy that designed this making $1 gazillion somewhere. But it came to him while he was having an argument with somebody at a bar, and he took the notepad and started making notes. He said, you know what, I think we can do this. And then poof, it changes AI, the whole industry overnight. Okay. Why am I talking about this? And related to a two transistor thingy? Well, it's all ones and zeros, and it's information theory. Information theory can go very, very, very deep. How do you encapsulate information that can be absorbed by another human or a computer? Facebook had two AIs that were working on developing a language. Well, they developed a language that nobody understood. So they turned them off. Skynet, anyone? Okay. And then the other hot topic right now is this machine learning. Some of you have probably heard of machine learning. Here's how I like to describe machine learning. People say it's AI, and I said, well, in its root form, yes, it kind of is. But machine learning is a little more restrictive than a generalized AI. I want you to think about driving. When you drive and you accelerate, you're going faster. That's called positive feedback. When you hit on the brake and you slow down, that's called a negative feedback. So if we're in a car and we're just controlling the speed, we have two feedback systems. We have the accelerator, we have the brake. So we just have two feedback systems, okay? Not much. Machine learning is an extremely sophisticated feedback mechanism that takes hundreds of inputs as feedback into the model to change the direction of where the machine learning algorithm is going. Okay. Machine learning has the idea of adapting to. AI has the idea of being trained to become. Okay. So those are the big worlds that are part of information as bits. And we are going to learn how to go between hex and binary. And if you've had my classes, you've already had the quiz. That's one of the quizzes, is that one where you just convert ones and zeros, and we'll do that next week. Then we'll get into how do you do math in binary. Well, I can show you adding. That's really fast. How many digits do we have in binary? 2. What are they? 0 and 1. That's it. So if I add them, what do I get? 1. Okay. What if I have 2 of them? I get a 0 with a carry. Welcome to binary adding. Just add a whole mess of bits and you can do your math. And you move bits left, right, shift, 2's complement, all this fun stuff. We're going to learn how to do that. Okay. And then from there, we are maybe do this, or I might bring in gates, logic gates, things like there's the and then we have the exclusive nor, like you see there, and then we have the or gate, and then we have the not that changes how it works. And this is all represented in ones and zeros. So I have a high voltage, low voltage on each one of these things, and it changes the thing. So actually using logic gates, this is how Steve Wozniak designed the Apple II. He learned logic from somebody in his high school, and he started writing logic gates and found an integrated circuit that had enough in it that to do what he wanted it to do, the 6502, and created the Apple II PC. Well, Apple II ancient version. And he did it all by himself just because he had an interest in how logic worked. The next level after gates here is, what if you want to deal with a trillion gates or a billion transistors? Then there's things called the hardware description language that allows you to write code that generates your chip. Okay. Bingo. And this hardware, now what he said with FPGA, that's right. It's basically, think of it as programmable hardware to do specifically what you want it to do. This is where that RISC-V I was telling you about Monday is making such big inroads. Okay. So think of writing code, you burn a chip, and that chip, it now becomes your new computer, or flies an airplane, or drives your car. Big money there. Okay. Gates, and then C to assembly. This is using the debugger, the magic of the debugger, where we actually write some C code, compile it, make it work, and then we show you what's actually happening in the registers. Okay, so it's that this right here, this is a ticket to a good payroll check. If you can debug code at that low level, okay, that's a real skill out of the rest of this stuff. The rest, a lot of this stuff is theory to understand how all this stuff works. And then we are probably get into this MIPS assembler, and then how to actually create our very own MIPS. MIPS is an encumbered thing. We could do the same thing with RISC, where you actually make your own RISC chip. But like most things, we don't have the tools on campus to be able to actually program our own hardware. That'd be awesome. But that stuff is not cheap. And the hardware side of the equation, the HDLs and how you compile and go to chip, and you, let's say, hey, I've got this great idea that's on a chip and I need to get one. Well, you really can't go anywhere and do that right now. You need to get 10,000 before you get your one. And that's big money to be able to set up a fab, burn all your chips, and then you get the first run of 10,000, and then you have to write the testing harness to make sure they all work. Okay. So we're kind of, so that's there, and then what it takes to process it. And we'll be, I might move these around a little bit, talk about memory, IO, and then some of the abstract stuff. Abstract in the sense of, let's talk about abstraction in a very general sense here. $99 bottles of beer.net. Go ahead, and you're all falling asleep on me. Go ahead and open your browser and go there. 99 bottles of beer.net. Okay, with the minus sign. Okay. Tinker away. Okay. So how many programming languages can you think of? Well, this website represents 1,500 programming languages. Pick one. Go find one. Let's start with one you probably know, Python. So go to Python. Browse languages and go to P for Python and PY here. And then they give you several to look at. All right. Let's assume you've never programmed before. Let me make that bigger. Can you kind of understand what that does, having never understood programming in your life? It reads kind of like English, okay? Which was one of the design principles for Python by Guido when he designed it. He wanted it to be easy for beginners because it came from a language he was working on at the time. And Python is one of the few programming languages that requires white space for your curly brackets, okay? So white space, indents really are important in Python. You may have all learned that the hard way, okay? You gotta indent correctly, okay? So this is what we call a nice high-level abstraction of writing the code for 99 bottles of beer on the wall. Okay. Now let's go to one that I'm really going to have fun with. PRO. If it's still out here, it may not even be out here. Let me see. I have others. No, they took it out. I don't blame them. It goes way, way, way back into history. Oh, here it is, PicProc. Yes, I can tell you how this works. And why would you want to know when you can actually read something that looks like English? This came off the database I have 10 years on that nobody uses anymore. And it allows you, these are stack commands that push things into the stack. Thanks. And pop from the stack. Oh, and they push and pop from the stack. And it prints the lyrics to 99 bottles of beer on the wall. Now that makes a lot of sense, doesn't it? Of course it doesn't. This is called a lower level of abstraction. Okay. Now let's pick one we are going to play with, assembler. Let's just look at one that they have. Yeah, I don't think that's it. I think, yeah, here we go. Which one do you want to look at? Let's look at assembler for MIPS, since that's what we'll be playing with, or RISC. Now, I want you to look at this. Notice how it's written out, and it says string dot command, and you have main, you have loop, and then you have this LI-A21. What's going on here? Well, we're going to learn what this represents. This is when you push and pull data into and out of a chip, you have registers. And you push data in, do stuff with it, push it back out. Well, assembler is written at this level, which is actually not the lowest level. It's still abstracted up because true programming in pure binary is in ones and zeros represented by hexadecimal. So you take AC and then BA and do something. Very, very low level stuff. Okay. Like on the, so this is actually abstracted up one. Okay. So let's look at, park risk. This is this park risk. Let's look at this one. This is what started, they don't have any, don't want to recommend. They didn't do it. Okay, let's go back one. Maybe it's not displaying. Let's look up, why didn't that one? Let's look at risk. Do they have it? ARM, that's good enough. Let's just look at, let's see here. We'll look at this one. This is a Raspberry Pi. So this is what you would do when you want to write for a Raspberry Pi. And this is actually running RISC OS. This is an operating system that runs on small computers, single threaded, single user. Doesn't run real fast, but it runs really, really small. Things like ATM machines. Perfect. Okay. And when I saw that Microsoft won a contract to put in and use Microsoft Windows for ATM machines, I said, oh boy, if I was a bad guy. There's just so many holes in Windows. Okay, I'm not, that's the stuff that gets you sent to prison. Okay. Okay. So have fun with looking at that. And then you can look at Fortran, COBOL, some of these other languages that, you know, COBOL is not going to go away. The reason I say that is there's billions and billions of line of code in COBOL. And if you have a credit card, you are a user of COBOL, because the way it works, COBL, here we go, uppercase. Look at all those words that you need to get 99 bottles of beer on the wall. It's called, I like to call COBOL a domain-specific language. And people aren't learning this. You don't go to school to learn COBOL anymore. You see these coding camps. There's a coding camp. Let's go learn JavaScript and Angular in 12 weeks and give me $30,000. Okay, you're going to learn it because you're going to be there 6-8 hours a day, 6 days a week, and doing nothing but coding. That's really a good way to learn it. The same thing happened in the 70s and 80s. They had COBOL boot camps. COBOL programmers can make a lot of money in the right place. Otherwise, it's 35 bucks an hour. You can make more as a web dev. Is this going to go away? No. What's happening? They're abstracting running COBOL code into modules that you import into a new code base. What? Which one? I don't know if Voyager does per se. If I was to guess, it's probably C, very low level. Oh yeah, the COBOL, and you know, maybe the stuff on Planet is COBOL, but there's another language that has a tremendous history, and it's one that I've actually gone back to revisit. It's called Lisp, and this the ideas in Lisp at the time blew everybody's brains out, because the whole concept of how Lisp works is what? But Lisp, some of the ideas in Lisp, you're beginning to see in Rust and Go. This idea of being able to write code, implement it, get it running, and then send it a patch while it is running. Think about that. You need to change your spark plugs while you're driving down the freeway at 60 miles an hour. Hot code is what they call it. Hot code changes. Remarkably complex. Lang is another language that supports it. This is stuff that scales to the size of Amazon. You can, okay? But Lisp, Larry Wall says, it has all the visual appeal of oatmeal with fingernails in it because they make fun of it. It stands for lots of silly parentheses or something because you have to use parentheses for everything. But it's one of those things. You can take this, whether you believe it or not. But Lisp, in the early days, there was this big religious war between Lisp and C, and C won. But the religious war doesn't rage so much anymore. There's good ideas here, there's good ideas here. So let's move to the next level and use good ideas from everything. This is why Python is so usable, because they take pragmatic ideas from other disciplines, other languages. You can do functional, object, imperative, procedural, all within one code base. That's important, okay? Anyway, all right, on that note, I will stop talking. And so next week, we will start on information as bits, ones and zeros. We're gonna have some fun. All right, questions? I'll hang out for a while. So, and I actually went over a few minutes, but there we go. So, all right, folks, have some fun. And now you can get your homework. Log in and start playing with it. Yeah. That's right. Monday's a holiday. My wife said, remember you tell them that Monday's a holiday? And I go, yeah, that's right. I forgot to tell you that. Monday is a holiday. Yeah, well, I won't be here. The campus will be really quiet.